All right, my lovelies, as Miss Dempsey would say. I'm going to start from number 18, constructing a stem and leaf plot. If you missed part 1 video, you might want to watch that one first. Remember, you always want your leaves in order. Your stems are all the digits except for the very last digit. So my stems are going to be 10, 11, 12, 13, 14, and 15. And then I just went through, my leaves are as follows. And then 5, 9. And then make sure you include a key so your audience knows that 10 bar 5 is the number 105. Number 19, create a normal distribution with the following mean and standard deviation. So I'm going to go ahead and draw my normal curve. Your mean is always directly in the center. Right at the first transition point, where it goes from downward cup to upward cup, would be 1 standard deviation away. So I add 0.3, and then our next important points will be 4.7 and 5.0. At the other transition point, I'm going to subtract the standard deviation. So this will be 3.8, 3.5, and 3.2. I'm going to do the same thing over here. My mean, 5, right in the middle. 2 transition points are going to be 4 and 6. And then my other standard deviations away, just like so. For the next problem, a survey of U.S. gas stations found that the price charged for a gallon of gas can be closely approximated by normal distribution with a mean of 350, so I put that right in the middle, and a standard deviation of 0.25. I sketched my normal curve and I labeled the 7 important points. The first one asks, what percent of the stations charge between 275 and 350? So let's look at this here. We went between 275 and 350. I noticed that that's 1, 2, 3 standard deviations away. I know that from plus 3 standard deviations away and minus 3 standard deviations away from the mean, between those 2 points is 99.7, but I only want from the mean to 3 standard deviations to the left, so I'm going to divide 99.7 by 2, and that'll give me 49.85. Part C, more than 3.75 for a gallon of gas. So that is 1 standard deviation away. I know that 68% is between these two numbers. So that means that 100 minus 68, or 32%, is in this tail and this tail. If I only want 1 tail, I'm going to divide that by 2, and I find that 16% is more than 375. Part D, less than 275 or more than 425. So what I want here is the 2 tails that are not in between 3 standard deviations to the left and 3 standard deviations to the right. So that's 100 minus 99.7, which is 0.3%. Let's do this guy in the calculator. You can use a z-score table as well. So go into your calculator and select second bars. Go down to normal CDF. Negative second comma will give you your E, 99, comma, plug in this number, 0.11, and you get 54.38%. They want us to sketch our curve, so I know that 0.11 is going to be a tiny bit to the right of the median, and I'm sketching to the left because it's a less than. Next, they want the probability that z is less than negative 2.9. That's going to be very tiny. Normal CDF, negative EE99, comma, negative 2.9, and I get 0.187%. 22 is pretty much the same as 21. The only thing that's going to be different is, since it's greater than, you're going to have to subtract from 100. So I got 99.74% for part A and 6.68 for part B. 23, they want the probability that P is between negative 0.68, or Z is between negative 0.68 and 1.3. Negative 0.68 around here, 1.3 is around here, so I want this. Second vars, again, choose normal CDF, but this time, negative 0.68, comma 1.3, and the calculator tells you that is 65.49%. I don't care where you round as long as you round correctly. And then part B, I got 14.99%. Find the z-score that is in the 48th percentile. Go to second vars, but this time choose inverse norm. It should be the third number down. And we want this number as a decimal, so 0.48, or you can plug in 0.48 either way, and you get negative 0.05. Remember, this is a z-score, so don't try to turn that into a percent. Part B, inverse norm of 0.22, and I get negative 0.77. We're on the home stretch. Describe the correlation and estimate the correlation coefficient for each of the following. The number of hours you studied and your grade on the test. Well, I think that as the number of hours I study goes up, my grade on the test should go up. So that would be a positive correlation. I would estimate the correlation coefficient to be a positive number, let's call it 1. Your shoe size and your locker number, well, those don't have any correlation at all, so I'd say none, correlation coefficient of 0. The number of years you have been skiing and how many times you fall, unless you're me, the number of years you have been skiing as it goes up, the number of times you fall should go down. So that would be a negative correlation. Let's estimate the correlation coefficient to be negative 1. Explain the difference between a sample and a population. A sample is part of a population. So maybe a population might be all the students at Northwest. A sample could be every third student who walks through the door. Why isn't a census used very often? Well, it's kind of expensive. It's long, tedious. You can go on. One last problem and then I can go home to Milo. Tell whether you would use a survey, experiment, or a simulation to gather data about the effectiveness of airbags. Well, that seems a little dangerous, so I would use crash test dummies in a simulation. How do you spell that? Simulation. The number of people who like dubstep, let's go for a survey on that one. We could just ask them. What happens when you mix vinegar and baking soda? That is an experiment. Happy studying, everyone.